Alright, I don't know what that was about. And we're live. Alright, so first off, questions about translations on the first page. No, we're good. So, question about the first page. No? Feeling great? Adding and subtracting, applying the vector, finding the rule. We're good with all that? You're going to need that today. I'm going to push you guys a little bit further than I did on my first hour class. It worked well with third hour, fourth hour, and fifth hour. I'm hoping it works well with you guys. So make sure you understand this crap. Next page. Simple reflections. Finding the rule. How do we feel? We did most of them in class yesterday, I know, but do you understand the concept? Number 6 was optional, self-development. Did anybody figure it out? Awesome. Get it to me Monday if you still want to work on it. 3 points if you can explain it. 1 point if you can get the rule. Yes. Questions on this? Okay. What we actually learned the other day, rotations. Questions on this page, 7, 8, or 9? All right, I'm going to do 2 of them. Let's look at number 7. Actually, let's do 8 and 9. Let's look at 9 first. No, we're not going to do that crap. All right, so we assume rotation about the origin yesterday, if it's not specified. Today we're going to change that up, but yesterday it was always the origin. So the idea is that we're going to rotate these about the origin. Imagine a string attached between the origin and B, and it's going to rotate it, right? That string is more like a stick. It's not going to change length at all. It's not going to bend or shrink, and it's going to rotate B. In order to make that happen, we're going to draw an L between B and our center of rotation. It's 0 unless at the origin unless otherwise specified. So imagine that we have a line connecting those. We got a little PFAG thing going on here, sort of, right? That's going to guarantee that this length doesn't change. Yada yada yada. If you don't get what I'm saying, that's fine. What we're doing is we're turning clockwise, 90 degrees. Clockwise, the way a clock goes, that's this way. A 90-degree rotation is going to be like this. So check out the blue. The blue is pointing this way, to the right. Oh, sorry, your left. To the left. If we turn that 90 degrees, and we're going clockwise for you guys is this way, what direction is it going to point now? It's going to point down. It's going to be vertical, and it's going to point down, right? Vertical is the up and down, right? And then down is the direction it's pointing in, so it's going to point down. So that blue bit right there, when I turn it, oh no, clockwise for you guys is not this way. Is it clockwise for you guys? My bad. I got a weird look from Sydney. Yep. So here we are, right? Clockwise for you guys is this way. Counterclockwise for me. So it's going to point up. 3 up. Notice the length did not change. And now that red part, again, you can think about swinging the whole thing, or you can think individually. I'd rather you think individually. I think you'll have less mistakes. Red part's pointing up, right? So when I turn it clockwise, which for you guys is this way, it'll point which direction? It'll be horizontal and to the right, because horizontal is either way, right? It's good to know both. So it's going to go to the right. Nope, it's still attached to the blue, right, like it was before. The question is it going to go to the left or the right? And the answer is to the right.
Oh, okay, now I see.
Better? Okay. So notice that L has swung this direction, 90 degrees. That means B is now moved to B prime, which is at the end of that. That's how we rotate it. Feeling good? Awesome. Notice that A shares the same leg as B, the blue leg, right? It just goes a little bit further. And then we cut up. So again, that blue line is going like this. When we rotate it 90, it's now going to go vertical, pointing upward. But it's just going to go a little bit further this time, right? 1 further. And then that red line is still going to go to the right just like the last red line. It's just going to go further. How much further? Looks like 1, 2, 3 further. And then 3 more. And so there's A prime.
How'd you figure that out?
So what I did is I took this line right here, rotated it up. Now it's there. And then this guy's pointing upward. When I rotate clockwise, it's now going to make it point to the right. So again, still attached to this blue right here. It's swinging. There is, sorry. Here it is. Schlaffer, try this.
There you go.
Okay. All right, here we are. when I rotate clockwise, it's clockwise, right? Okay, clockwise for you guys is this way. Now it's going to be like that. You dig? Okay. Again, you can think of it all together like this, or you can think of it individually. Red is vertical to start out. If I go clockwise, 90 degrees, it's now going to point to the right. Okay? So now it's still attached to the blue, but going to the right. Same distance. A prime, doesn't matter right now. We're going to figure that out in a second. The length is 6 here. Does that help? Okay. C shares B's blue leg. It's just a little bit further. And then goes up 3. So instead of going to the left, it's now going to go up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then to the right 3. Because what was once vertical is now going to be horizontal and going to the right. So that's C prime.
I did C prime on my own. I feel good about it.
Dope. So here is our triangle.
See the box under it. See the box under it can confuse you though.
Yeah, it can. Yeah, the lines that you draw might get confusing.
What's C prime score?
C prime is 3 comma what? 1, 2, 3, 4, 5, 6, 7. 3 comma 7. So let's talk about what the rule is. A is negative 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. B is negative 3, 3. C is negative 7, 3. Does that check out with what you guys have? Okay. A prime, we said, was 1, 2, 3, 4, 5, 6, and up 4. So 6, 4. B was 3, 3. And C prime is 3, 7. So what happened here? X and Y switched. And which one changed? The negative 4 became positive 4 for this one, right? So this changed. So that's our rule. That's the rule for a 90 degrees clockwise rotation. Flip them and make one negative, right? Now the question is, why is that the rule? Well, because that's how it worked, right? No. Explain. Why did that make sense?
Because 2 negatives.
Did you flip it over the axis? No.
That's for reflections.
Math.
Let's talk. All right. So, pick a point, pick a quadrant. Let's pick this one. This quadrant, whatever the coordinate is going to be double positive, right? You dig? Now, if I turn 90 degrees centered about the origin, that's going to make it end up over here, right? Somewhere. This quadrant, negative x, positive y. Notice how one of them changes. One of the signs changes. Why do the numbers flip, though? Like the x and the y. What do they flip? Look at it.
Well, you're flipping over the y, and the 7 is flipping over the x.
I think you're thinking of it like a reflection. It's not a reflection. But good thought.
Wait, what did you ask again?
Why do the x and y switch spots? So I think we understand why the negative signs change, right? Because when you switch quadrants, no matter where you start, right? If I started here and I do a 90-degree rotation, I'm going to end up double negative, right? So one of them changes, right? There's always going to be one sign changing whenever you rotate 90 degrees. When it's centered on the origin, which it won't be later today. But otherwise it makes sense. Okay, it's fine. You'll be okay. How about this? Look at number 7. I'm going to do this really quickly. I'm just going to rotate B. Actually, I'll do the whole triangle without drawing my L's. So here's C prime. B would be here, and then A would be here. Trust me on that. And I'll draw the L for B and B prime, actually. So here it is. This is going to help you think about the question I'm asking. why do the x's and y's switch? Because they do for this one as well.
Because you're going from a positive y to a negative y.
What do you mean?
Like, if you look at the left one, negative, positive.
That has to do with the sign changing. I'm asking, why do x and y switch spots?
Oh, I don't see
Yep. Why do the x's and y's switch spots for a rotation like this? Yeah. Give me your thoughts.
Starting out horizontal and then moving it vertical.
She's absolutely right. Do you know what you mean, though?
Uh,
Not really.
well, no, you see patterns.
Okay. She's absolutely right. Keep looking. Somebody explain it to me. Why do the x's and y's switch spots? May.
Like you see the line, the blue line, like originally it was horizontal, and then after you rotate it,
Exactly. So check it out. This is some x value, right? But that same number later changes to a y value because what was once horizontal became vertical. What was once horizontal became vertical. Horizontal's x value, right? Vertical's y value. They switched. Same number, right? But what they do is different. So that x is going to end up over here. Let me do this.
Pretty neat.
Same number, it's just one's going to be a vertical, right? We went from horizontal to vertical. Look at this value right here. That's a y value, right? It's vertical. But when it shifts down here, it becomes an x value. The x's and the y's switch spots. What once was vertical became horizontal. Now, that's not it. This x, positive or negative? Negative, it's going to the left, right? We got -6 going on here. What about this one? Positive or negative? Positive 3. What about this? -6. So the sign didn't change here and here for our blues. But they did here, because that's a positive 3 now. I'm sorry, -3 now, isn't it? It was positive 3 here, but now it's negative. It's going to the left. So our negative is going to occur here. What once was positive is now down here in negative. It's in the x's spot, but it's negated. What once was vertical and going upward is now horizontal, so they switch spots, and now it's going to the left, so negative. Down here, what once was horizontal is now vertical, so x's and y's trade spots. This guy was negative, now he's positive. What once was horizontal and positive is now vertical in the vertical spot and negative. Do I have you about 50%, 25% of understanding here, seeing this concept?
I understand.
We are flipping and negating, yes, but not reciprocating, right? That's not what's happening here. We're not flipping the fraction and negating it. We're changing spots and negating. Why, though, is the question. Do you understand why that's happening? What once was horizontal now becomes vertical. They change spots, right? X's and Y's switch. Vertical and horizontal switch. Why is it negative and positive switching? Because this guy was a negative and now he's a positive. Was a negative, now he's a positive. We changed the sign. What? Similar. We're going to go look at number 8 now. Yeah.
Can you explain how you use that as a, like, I get why you use that, I'm just confused on how to use that as a formula.
Okay, so if you look here,
Yeah.
X and Y switch spots, so our numbers switch spots. 4 and 6 switch spots. And then this guy, his sign changes. Remember, negating something changes the sign. It doesn't make it negative necessarily, right? So was negative, now he's positive. Better? Cool. Let's look at 8. I'm only going to focus on C because A and B have zeros in them. If we negate zeros, right, they stay 0. It doesn't give us as much information. So I'm just going to flip C to save on time. We did this in class the other day. There's the L. I am rotating 180 degrees. It doesn't matter whether it's counterclockwise or clockwise, because if I start here and go counterclockwise, sorry, you're clockwise. If I start here and go clockwise, I end up there. If I start here and go counterclockwise, I still end up there, right? Doesn't matter the direction. So I'm pointing this way. I go 180 degrees. Here's 90. Here's 90 again. Which way am I pointing now? To the left. So that blue part's going to point to the left. Same amount, 1, 2, 3, 4, 5, 6, from our center of dilation, or sorry, center of rotation. Red part, pointing up or down? It's down, but what will it be later? 90, 90. It's going to point up. So there's where C prime is. Let's look at the lines and not write the coordinates yet. Let's talk about the rule. What is happening here? What once was horizontal is still horizontal, right? So do the x and y's change places? No. Still horizontal, right? Still vertical. However, the direction changed. This guy was going to the right, now he's going to the left. Direction change, minus sign. This guy was going up, now he's going down. Direction change, minus sign. You smell what I'm stepping in. X and Y trade spots, or stay the same here because still horizontal, right? Still vertical. But the direction changed. So that's the formula. Now if we check that, here's C, and here's C prime. Sorry, that's a C. C's coordinates, 1, 2, 3, 4, 5, 6, 7, minus 2. If we apply this rule, we would expect a negative 7, positive 2. Let's check it. Negative 7, positive 2. Checks out. Small one stepping in? Yeah. Yeah, that's cool.
Do we have to have the lines on?
No, I just want the answer. Don't try to eyeball it. Know what's going on here. Next week on your quiz, I'm not going to have you explain this so much, but I will eventually. I might have it. I don't know. You'll find out on Monday.
So for A and B, would it just be like 0, -4, 0, -8? Right? No?
Yes.
So do we need an exam or like quiz?
Negative 4, 0, negative 8, 0. What?
Oh.
No, I was talking to Schlaffer. What did you say?
Is it going to be like a quiz or a test?
Quiz. It'll be this homework plus what we're doing today. Do we see why these rules are what they are? They're not rules to be memorized. They're rules to be understood. We change the x and the y when the vertical becomes the horizontal and the horizontal becomes the vertical, right? We change the sign when the direction changes. If we go from horizontal to vertical, that means we're changing x and y's, right? If we go from up to left, right, that's a positive to a negative, then we change the sign. If we go from left to down, that's a negative to a negative, no change. Again, what changed here? Both of them. The 7 became negative 7, so we changed this one. The negative 2 became positive 2, so we changed this one. Negating means change the sign, not make it negative. What happened here? X and Y switched spots. The negative 4 became a positive 4, so this one changed its sign. That's number 9. What?
I was going to ask for number 8 for the base one, normal triangle.
Mhm.
Is one side longer than the other? Or
No, they're both 2 by 2, or 4 across. For the base, yeah.
Wait, is 7? I mean, is C 7 for X or 6?
For what problem?
For 8.
For number 8, C is 7, negative 2, I believe. Nope, it's 6. My bad. Minus 6. Same principle. Minus a half to me. All right, how do we feel? Dece? I'll take Dece.
I feel pretty good about it.
Here we go. I've got a big, thick packet for you, and I can explain why. Okay? Relax. Everybody likes to whine about it. Trust me, it's not as bad as you think. Here it is.
What do you say though?
You just gotta trust me. I've never led you astray.
We'll see.
I said not to trust you.
No, we'll be on this for now.
I'm not setting one until it's just paper, okay?
None of you are individuals. You're all just copies of each other.
Yeah, we're just
Not
we're twins.
Set it up. don't know what that means.
Magnolia did not get one. Magnolia.
And then if we're moving to the axis,
Yeah, Cindy didn't get one.
We didn't get
We're talking about
packed.
this one? I know! This one is what we're talking about? So we're moving that way?
no, when you're trying to find C, when you're moving left 6, would that be negative 6? Because you're moving left.
This is to the right.
What do you mean?
Right hand, left hand.
Oh, okay, so, okay.
Okay, good.
You're on
I know you didn't get packets, so I'm trying to figure out why I don't have enough, or if I have them somewhere else. Why
I
don't
guess you don't get one, Cindy. You have mine. No.
I've got these two here.
No. You sure about that?
Oh no, you're gonna get one. Don't worry.
We can share.
I'll be back.
I just got.
Ooh,
What? Okay, I get it.
Oh, really?
I'm gonna ask him.
I wouldn't know what to do. Well, yeah, to make a test.
Alright, as you might have noticed, these are not going to be centered around the origin. We're not going to rotate about the origin anymore. They give you the point of rotation. So the first thing you want to do is you want to plot that point on your graph. We're going to start with this one right here. I will get you a packet.
Oh, I have a question.
What?
Danny is upset about his phone.
Yes?
He wants it back.
I don't have it.
-1.
Why don't we all sit on the damn bunny bench?
Get off your phone. That's what I posted that on my. Hey, that is my water. Stop it. Oh, what? What the hell?
Smoking Jake joints not. The answer to.
Are you calling?
Yes, Jasinski.
Sorry. Thomas threw my water in the recycling bin.
Why? Why?
Morley, is that Morley?
Why? My question.
It's because he
Sorry.
doesn't trust you.
Are you from
Yeah. Why are you calling Danny?
Because I don't know what I'm
Anybody else get a package? How's it get? There you go.
It don't sound like Danny, buddy.
Do you have?
That's his voicemail, I guess. What if it's his dad?
I don't have it. I don't have it. I'm not lying.
Is his dad named Danny?
Say, what if you got his dad's phone?
Oh, idiot.
I didn't know that. I'm sorry, I didn't know you bought a new phone.
Alright, so we have one now. We good? We good? We good? Awesome.
Wait, so is this packet gonna be homework too?
Every class, the same question, the same lack of patience. Alright, so, and I can prove it because I have it on camera. Alright, so, you gotta trust me. Here's what's gonna happen. No. Now we're recording. Here's what's gonna happen. Yes, this is homework, but I never assign homework on the weekends. I know I didn't. Here's what's gonna happen. All homework is due the day of the exam. When's the exam? It's on Tuesday next week. So technically, I'm assigning this Monday, but I'm giving it to you ahead of time so you can get it done. You're welcome. So if you don't want homework on the weekend, great, do it Monday. You do want homework on the weekend so you don't have it Monday, great, do it over the weekend. Up to you. Or just don't do it, because guess what? On page 2, page 4, and page 6 are the answers. Why did I give that to you? One, so you can get practice. That's what homework is for. I'm not here to punish you. So yes, you can literally just do that, and it's done, and you can turn it in. Why am I doing it where you turn it in instead of just saying no grade? Because I'd rather give you a grade than not a grade. It's 3 points. You're welcome. Why am I giving you examples? That way you can be ready for the quiz that's on Tuesday, because you're going to have to do this on Tuesday. Are we going to have time to go over the homework in class on Monday? No, because we're reviewing for the quiz on Tuesday. So we are going over it by doing 2 of them today, and doing the rest with the answer key.
Mr.
Did you say you'll never give us homework that a bunch
Exactly.
a bunch of the same exact problem?
Right. I didn't give you homework of a bunch of the exact same problems. You don't want to do the remaining 4 in there and you're done? Great. Copy down the answer key and turn it in.
It's in there.
Second one. See the first page?
There is no downside to this for you. 0 downside. It is all roses. Okay? So, here's what we're going to do. We're going to do the first 2 together. The rest of it, you need to turn in on Tuesday. You have plenty of time to get it done. If you don't want to do it, then just copy down the answer keys. Right, okay, good. I know. Imagine when you, remember a long time ago when I was in your math teacher and you had like a million problems of homework every night? Yeah, exactly. Stop your whining. Even the max assignment I gave you the answer key for. I give you the answer key every single time if I had it made ahead of time. And I normally don't, right? Because I'm barely able to get this stuff down the night before because I'm running around like crazy trying to get this all done for you guys, right? But this one came with an answer key, so I gave it to you. Homework is not meant to punish you. Moving on. All right. Here we go. We're going to call that point R for our center of rotation. Okay? We're not calling it C because we often use C when we're labeling our vertices, right? So I call it R. No. So let's rotate this image 90 degrees. In order to do that, so we all know what we're talking about, we're going to label our vertices. Label that one A, label that one B, and label that one C. R is for our center of rotation. It's no longer the origin for this problem. Yes, Lauralee?
Never mind, I'm stupid.
No, it's okay. What's your question?
No, I figured it out.
Wonderful. That doesn't mean you're stupid. That means you're smart because you figured it out. Good job. All right, so now we're going to rotate about that. So how's this going to work? Well, it's the same thing what we were doing before. It's just we're all going to draw our L's towards this guy instead of the origin. So A is really easy to do. You don't even need an L. You just need one stick. We're going to rotate this clockwise 90 degrees. Well, right now, A is pointing this way. Right? To get to A, we're going that way. If we do 90 degrees clockwise, for you guys, that's this way. So it's going to go up, right? So from the center of rotation, which is R, we're going to go up 1, and that's where A prime is. Wow. There's A prime. Yes. Actually, it's going to take both. Full understanding comes from both. All right, so next thing, we're going to flip B, and by flip I mean rotate. Flips the reflections. So notice they share the same blue leg. This one's just longer. And then it goes up, so we actually have an L. We'll pause for station identification. Yes.
It's not related to math.
Should it wait? Should it wait?
It's about me. It's a quick question.
Will it distract everybody from understanding what's going on and have a break in the flow?
Yes.
Yeah, then let's wait. Then let's wait.
No.
Okay. Let's wait. Oh man, this thing is a disaster. All right, so blue line. It's going this way. When we flip it 90, it's going to go up, just like the last one. It's just going to be longer, right? So here we go. It's 1, 2, 3, 4, 5, up. So that's to there. And now we got to do the red part. The red part will still be attached to the blue, right? Red is going up. When we rotate it clockwise 90 degrees, for you guys that's this way, what direction will it be pointing? To the right. So from here to the right, 5. 1, 2, 3, 4, 5. And that's where B prime is going to be. How do we feel about that so far?
Good.
Sydney?
Good.
Awesome. Anna? Fantastic. Autumn? Yeah? Great. That's fine. Please do. Next thing we're going to do is we're going to go get C. So from our point of rotation, our center of rotation, we're going to go to the right, and we're going to go up. I would highly encourage you to get colors like I do. So there's our L. The blue line is this way for you guys.
Yeah.
When I turn it 90 degrees clockwise for you guys, that's this way. So it's going to point down.
Yes.
So we're going to go down 1, 2, 3, 4, 5, 6. The red line is pointing up. When we go clockwise for you guys, that's this way, 90 degrees. Which way is it going to point now? It's going to point to the right. So our red line is going to go from here. To the right. How many? 1, 2, 3, 4, 5. There's C prime. It's okay. Go ahead. What?
Like, did you? I don't know.
Clockwise is this way. This leg swings down.
To get down to is it only from your point down to rotation?
Okay.
Yeah, we're rotating each individual point 90 degrees.
All right.
Better?
Yeah.
And again, it's easier if you break it down into segments. That's a 90-degree rotation there, right? And this guy, if you flip him 90, he's going to be like that.
All right.
Better? Awesome. Thank you for asking. Now we connect those, all the primes. Make sure you don't connect your original points. Sometimes that can be misleading. And I'm going to color that in just to make it nice, so you can see where it is. And if you look, here's the original that we just did, and here's the answer key. Aw, look at that. That's kind of neat.
One of those books where you
I know. They call it a flip book.
Yeah.
Oh.
Next one. And then we're going to talk about the real thing I want you to learn today. Again, this is new-ish, but it's not much. The real thing I want you to learn is coming up next, so hang on to your butts. Make sure you're really paying attention now. That way you're not lost when we go to this bigger thing. Okay? So, 5, -5 is our center of rotation. I'm going to plot that right now. 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5. There's my center of rotation. I'm going to call it R because I'm going to use C for the triangle, right? Let's label our triangle vertices like this. A, B up high, and then C to the right.
Does it matter how you do that? Label.
I would label it the same as me for now. That way you can follow along, but in general, no. I just want to know, is everything okay? You look distraught. Are you all right? Okay, good. All right, I just want to check.
She's not okay.
I just care about you. All right. So, let's flip, or I shouldn't say flip. Let's rotate A first. So from our center of rotation, we're going to draw a line and another line to make our L. Little bitty red part. Little bitty. Real small.
That's tiny.
And there we are. Now to rotate that, again, look at the individual segments, don't look at the L altogether, right? We're going from here, we're going to rotate 180 degrees. Now when we rotate 180, they didn't specify counterclockwise or clockwise. The reason being, it doesn't matter. If we go counterclockwise, sorry, clockwise for you guys. If we go clockwise 180, we end up here. If we go counterclockwise 180, we still end up there. Doesn't matter, right? So when I do this, it'll be a lot easier for me to do because I won't have to think about what it looks like for you guys. So when I rotate that blue line 180 degrees, 90 once, 90 twice, which direction is it going to point now? To the right. So it's the same thing, but pointing to the right. 1, 2, 3, 4, 5, 6, I think is how long that is. 1, 2, 3. Yep, 6. Cool. The red part is pointing which direction currently? Down. Awesome. When I flip it 180, it's going to point up. Still 1 in length. And there is our A prime. Now here's the thing. Didn't we say earlier that the rule for a 180-degree rotation was to negate the x and the y? A's coordinates are -1, negative blah, 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 right? If we negate both those numbers, are we going to get A prime? No. Where are your gods now? That's right. See, what happened was, and this is fine that your teacher did this because they needed to set a foundation, okay? Sometimes we lie to you guys in order for you guys to make it through, and then we tell you the truth later and it blows your minds, right? So, I'm going to give you the truth. Memorizing the rule does nothing because guess what? As soon as I move that point of dilation, everything goes out the window. You have to know what it means. Not dilation, rotation. We'll learn about dilations later. So, it's useful to have that basic understanding if it's actual understanding. Why do we negate both the x and the y when we rotate 180 degrees? Well, if we start here and we go 180, notice they both change. If we start here and they go 180, well, they both change as well, right? Down here's this. But as soon as we move that, that changes, right? Knowing this is good. This is good. but not going to be good enough. So let's do the rest of ours. Let's rotate them. Let's rotate B. Notice B and A share the same blue leg. It's just B's red part goes up a really long ways. It goes up 11. I know that because I have counted so many times today. I have it memorized. So, same blue leg. Red leg from before is going vertical, going upwards. If I rotate 180, which way is it going to point? Downwards. So it's going to go down 11, which is all the way except for the last square. And that's where B prime is going to be.
Why don't you have to go right or left anywhere?
Because it has the same blue part as A. We had already done it. You see what I'm saying? Yeah.
You're how many?
Down 11. So it'll be all the way to the second to last square. Not the last square, but the second to last. Cool. Let's go get C. Notice they share the same blue leg as A. It's just a little bit shorter. And then it cuts upwards. So it's going to be the same here, but 4, right? And it's going to go down instead of up, right? And it's going to go down 9. So 2 less than B. There's C prime. Again, the idea, 4 to the left becomes 4 to the right. All that up becomes all that down. 9 is the number. Now let's connect our dots, and we've made our rotation. And I'll color it in, because colors are fun. Ta-da! And if I do it right, how do we feel? Okay. The rest is on your own for practice. That way you won't bomb the quiz on Tuesday. Now I'm going to blow your minds. We're going to find out what the rule is for these guys. So let's just focus on 2 points. Let's focus on C and C prime. And let's find their rules. So here's what I'm going to do. I'm going to zoom out. You're going to watch and not write anything. I know you're like, I want to get the homework done. The answer key. You have nothing to do right now other than watch. Okay. So, somebody that's helping me out here, tell me what C's coordinates are for number 2. C. It's okay. 1, 4. When we got the rotation, C prime, what is its coordinates? What is C prime's coordinates? I'm calling it triple prime. I'll show you why in a second. What were the coordinates that we just found for C prime? Like 6 to the right, 6, negative 14, 9, negative 14?
I have like 9, negative 13.
I think it's negative 14, if I recall correctly. Double check that. I don't want to screw that up. It's Grim. She has it.
I got negative 13. I had 9, negative 13.
No, I gave it to her.
G. I had 9, negative 13.
Telling all of his teachers that, guess what? Danny's not going to have his phone today. I didn't take it in my class. I took it at the end of my class because I don't care if he's on my phone. But imagine how annoying it's got to be for every other teacher, right? That isn't me. So I just decided to give him like a Christmas present. Happy Friday, Danny's teachers.
I had 9, negative 13.
All right, is it negative 13, not negative 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14 for there. It's okay. It happens. It happens. No, you're not, and don't use that word. All right, so that's what's happening. So how do we get there? Right, it's obviously not just change the signs, even though that is the rule for 180 rotations, right? Here's what's going on. Our center of rotation moved from the origin to here. What we're going to do is we're going to move it back. How do we move things? How do we slide things? What do we call that? Como se dice? Como se dice means, how do I say that? When you ask, how do I say that, what you're really asking for is the, how do I move things? The translation, exactly. So we move things by translation. Translations are done by what? Starts with a V. Vectors, that's right. So we're going to use a vector to move this. Now, when we do a vector, we apply a vector, right? Vectors aren't about location. They're about direction and magnitude. Vectors affect everything. So if I do this and vector it up to here, I'm doing that to everything, including my prime points and my original points. Those should all be the same length. I'm just sketching them real quick. We're moving everything over. And by doing that, what we're essentially doing is we're changing our axes to be down here. And everything shifts over. That's the magic, okay? So, the vector that we're going to shift these by is this green vector right here. That's 5 left and 5 up. So the vector that's going to shift these guys is going to be this vector. 5 left and 5 up. Why are we doing that? Because we're moving everything 5 left and 5 up, including this point. That's going to screw up our answer a little bit, but it's going to make us be able to use that 180-degree rotation rule, because now our center of rotation is the origin. So I'm moving everything, our center of rotation, to the origin. And when that's on the origin, we know the rule for 180-degree rotation. It's negate both the x and the y, right? So we're shifting everything over there. That way it's all kosher like yesterday. So how do I apply a vector to a coordinate? Whoops. Yep, yeah, I'm just going to do that. This is our slide, our translation, our, so we're going to slide it by this. What does this become when we slide it by negative 5, 5? Negative 4, 9. 1 minus 5, 4 plus 5. So when we shifted everything by that vector to get everything recentered, this is where that ends up. So C prime is now at negative 4, 9. So here was C. Negative 4, 1, 2, 3, 4, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It moved everything up this way, which is what we would expect, right? Cool. Now that everything's recentered on the origin, we can apply our 180-degree rotation rule. So now we're going to rotate by 180. What's the rule for rotating by 180? Exactly. And we know why that is. Because no matter where you start, it changes both signs. Right? Cool. So now, I'm going to call that C double prime. What's our coordinates going to look like? I'm going to zoom out. What are those going to look like after we apply the 180 rotation? Yep. Okay. But here's the thing. I'll show you in a second. Did we end up where we were supposed to? No. So what happened? Why didn't it work? Because we shifted everything over. And now we got to shift it back. We shifted it over so we could do the rotation. And now we're going to throw it back. And now it's going to move it back to where it's supposed to go. After we did the rotation, we got 4, negative 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's C double prime. And we're looking for C triple prime. We're going to slide it back. How are we going to slide it back? Well, before we slid it by negative 5, 5. I did that wrong. This isn't here. It's 4, negative 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see it? And now we're going to slide it back, and we're going to get where we need to be. So we slid everything here, centered it on the origin. We rotated it. Then, after we rotated it, we ended up here. Now we're going to slide it back. So how do we slide it back? We slid it originally by negative 5, 5. So now we're going to slide it by what? 5, negative 5. Right? When we do that, we get our final resting spot. What do we get? 9.
Wouldn't it be, do you have to do all this stuff if you just, like, you know, you go on 180, you write all your regular base coordinates?
I want you to pause right now. So,
Yeah, I'm sorry.
no, it's okay. You're the good thing, but you're breaking my flow. Bring it back in. I'm not going to lose you. Stay here. We took our original point. We slid it to recenter it on the origin. How did I know how to slide it to the origin? Well, I needed to go negative 5, 5 to get there, right? I used my vector. After I move to the origin, everything's hunky-dory. I can just flip it or rotate it like I normally do. Negate the X, negate the Y. Then I have to slide it back, and we're home free. What's your question?
Can't you just like, once you have your base coordinates and once you rotate it, you just, like instead of doing,
Instead of sliding it?
I don't know.
So check it out, Schlaffer. Here's C. If I negate both of its values, do I get this? No way, right? That's way too far off. And it's because this thing is what it's off by. So we have to account for that by resliding it to the origin, rotating it, and then doing our slide back. Yeah, you do. You have to recenter it. That's if we want to talk about the rule. You don't have to do that for your homework. You don't have to do it for your quiz. We're going to have that on our next quiz.
No pass for homework.
Yes.
Today's the risk magnet is gonna be long.
Great. I want to know.
I'm gonna save it for college.
Yes. 7.
You're here after school?
My handwriting is just so bad right now.
Come visit you after school.
Do it.
As long as I possibly can.
Do it. Today's the day, huh? You're gonna be in here, sitting in here today after school. Why does everyone pick Friday as the day to come in? Don't you have lives? Yes, that's fine.
Are you in here after school?
Yes.
I think Friday is like the only day I have as much time as possible.
That's crazy.
Is there a lot of people coming in from school?
Yes. And I don't know why.
I will ask.
I got dinner plans on Fridays sometimes, right? Right? Got things going on. Going to see Frozen 2.
You guys don't want to be mad.
No one wants to see Frozen.
Neither do I. Here's Shabakadoo.
I want to see Cars 4.
Cars 9. Now that's what I call music 87.
I see you on the shit. You're on the shit kickstand, guys. What? I'm doing this.
Bro, we had fat testing the other day.
Yeah, what?
Fat testing.
I don't know what that means.
Well, you got pee in this cup.
Oh,
You
got
pee in
it.
this
Got
cup.
it.
Okay?
Yes, yes.
And my pee
Okay,
was bad.
I need you to stop while I'm on.